Good day, grade 12 learners. Welcome to our mathematics lesson. I am Sikhulile Ncube. This lesson is proudly brought to you by the Gauteng Department of Education in collaboration with Saibono Discovery Center and is being broadcast by Pagama Research and Development. Right, today, grade 12s, we are going to be doing an interesting topic. Did you do this topic in grade 11? I hope so. You have an idea, but we're going to be mainly revising Euclidean geometry. We're going to concentrate on the center theorems. Okay, right. Remember, you are not just watching me presenting the lesson. All of us are involved. So make sure that your book is there with you, your pen, your calculator, and everything, and you're going to be doing the activities that I'm going to be giving you. Okay. Right, don't just sit there and listen. You're not going to learn mathematics by doing that. You learn mathematics by doing it. Okay, right, let's move on. What are we going to do today? You will revise grade 11 circuit geometry. Okay, that's what we're going to do. Right, let's go straight to a small activity. Do you remember the components of a circle and its terminology in circuit geometry? I want you to answer this. Name line A, line B, line C, line D, and line F. I want you to give these lines their names and then name the regions E, G, name the regions E and G, and then name the component H, this component here, the red one. What is that component H? I'm going to give you 2 minutes because you're not calculating anything here. Okay, 2 minutes to just name the lines and the regions and this component H. Let's try that for 2 minutes. Welcome back, grade 12s. Did you manage to answer all the questions here? What is line A? What did you write? It is very, very important, grade 12, for you to know all these terms. Okay, what is A, what is B, what is C? You have to know those things so that you can understand. When I say an arc, you must know what I'm talking about. When I say a chord, you must know what I'm talking about. When I'm saying a segment, you must know what I'm talking about, isn't it? If I say it's a tangent, you must know what I'm talking about. Okay? Right, let's name the items now. What is A? A is the tangent. Right, what is a tangent? A tangent will touch the circle at one point. It just touches the circle at one point. And then what is B? What is B? B is a secant, not a chord. You see that? What is the difference between B and the chord? B will cut the circle at 2 points. You see that? That's a secant. That's a second. Okay? Right. There's a difference between a second and a chord. Then C is a diameter. Diameter from this side of the circumference passing through the center to the other side of the circumference. You see that? That's diameter. Okay? And then from C, radius. Radius is from the center to the circumference. And remember that diameter is 2 times radius. Do you know that? Or radius is half of diameter. Okay? Right. And then F, what is it? It's a chord. It's a chord. Right. Very good. We use these terms a lot, especially the tangent, the chord, the radius, and diameter. We use them a lot. Right. Do you know that diameter is a chord? Can you say it's a chord? Is there any difference here between this chord F and C there? You see that? Diameter is actually a special chord because it is special because it's a chord that passes through the center. Okay, otherwise diameter is a chord. It's a special chord. It passes through the center. So that's a chord there. And then we've named what? E. It's a sector. Okay, E is a sector, and then G is a segment. What is H? What do you write for H? This red part here, what is it? It is an arc. Right, we're going to be talking about these things today. Angles subtended by the arc. Okay, you must know what you're talking about. Right, okay. Right, there's something else that we're going to use today. But we've been doing this, grade 8, grade 9, we've been doing this a concept about triangles. Do you remember congruency and similarity? Okay, congruence, what is the meaning of congruence? It means the two triangles are exactly the same. Okay, and there are 4 conditions of congruence. What are those 4 conditions? Remember, grade 12s, you're not sitting there and just keeping quiet. You must say, if I ask you something, you say those answers. Okay, you say them loud. Right, remember the 4 conditions for congruency? You must remember them. I'll remind you. Let's look at this one. We are required to prove that triangle ABC is congruent to triangle DEF. It means these 2 triangles are exactly the same. Okay? Right. Now, let's check. What are we given? We are given that BC is equals to EF. Do you see that? Because of this and that. BC is equal to EF. Given. What else? Angle B, which is this one here, is equal to angle E, and both of them are equal to 90 degrees. It's a right angle. Do you see that? Okay, so these 2 angles are equal. Okay, then what else? We're given AC. What is AC? What do we name? It has a special name. AC and DF, they have a special name. What do we call them? We call them a hypotenuse. Hypotenuse, right? The longest side of a right angle triangle, hypotenuse, or the side opposite the right angle. You see this thing? It's like an arrow. You see, if I draw like this, if I draw like this, I draw like this, it's pointing to the hypotenuse. So AC and DF are the hypotenuse. So now, and then they are equal because it's indicated here that these 2 things are equal. These 2 lines are equal. So they are equal. Now, what can you say about triangle ABC and triangle DEF? What can you say about them? They are congruent. They are congruent. Why? Because of right angle, hypotenuse, side. Do you remember that? Okay, we're going to be using this concept when proving our theorems. Okay, right, so we're saying triangle ABC is congruent to triangle DEF because of right angle, hypotenuse, side. Okay, right, and then we can conclude here and say AB is equal to DE. We say eyebrow, and then smile. Okay, so AB is equals to DE, and then BC is equal to what? Draw another eyebrow. BC is equals to EF. Okay, BC is equals to EF. What else? And then we draw a smile. AC is equals to AC is equal to DF. It is very, very important. We are going to be using this concept in today's lesson. Okay, right. Now, let's move on, grade 12s. Let's move on. I'll try to be slow so that we can move together. Okay, right. And then today we're concentrating on what? On the center theorems. Okay, and then the next lesson we're going to talk about another theorem. Okay, other theorems. Okay, right. Now, okay, I want to remind you about the other congruency conditions. We talked about the right angle, hypotenuse, side. Right, we can have side, side, side. If all the sides are equal, then the two triangles are equal. Remember, this one will be a common side, so it will be what? They'll be equal because it's a common side. Okay, and then here we have what? Side, angle, and then side, the common one for the two triangles here. And then here we've got angle, angle, side. Okay, right. We can have other conditions for this one. Angle, side. You can have angle, side, angle is fine. Okay, but angle, side is still okay. Okay, right. So there are 4 conditions for what? For congruency. Remember those, grade 12s. Are you ready for us to move on? Let's try. Right, now, the interesting part. We're going to the theorems now. I want you to understand. Some of you may be revising this. It's not a new thing. But some of you, maybe you didn't cover it well. You're still confused. I'll try my best to assist you. Let's assist each other. Remember, you're participating. Okay? Right. A line drawn from the center of a circle. Please understand everything that I'm going to be saying to you. Okay, I'm saying a line drawn from where? From the center of a circle, perpendicular to the chord. A line drawn from the center of a circle, perpendicular to the chord. Let's do that, just that part. A line, you see, the line is drawn from where? From the center. Okay, and then is perpendicular to the chord. That's the condition up to here. A line drawn from the center perpendicular to the chord. What does it do? You see, you have to try to break it into 2 parts. The line drawn from the center of a circle perpendicular to the chord, what does it do? What does this line do? It bisects the chord. It means it cuts the chord into 2 equal parts. Bisecting means you are cutting the thing into 2 equal parts. So a line drawn from the center of a circle perpendicular to the chord bisects the chord. So it means here we have 2 parts. AB is cut into 2 equal parts, and then AM is equal to MB. We are going to prove that. We are going to prove that if there's a line that is drawn from the center perpendicular to the chord, is going to cut the chord into 2 equal parts, meaning that AM in this case is going to be equal to MB. We are going to prove that. And then how do we do it? Okay, before we go there, this is an examinable theorem. Please remember that. You must know which theorem is going to be in the exam. I mean the proving it. So the proof is very, very important. You are getting all the marks from the proofs. Every paper, there is a proof question. So no one is going to lose marks on proofs. Okay, just pay attention. Right, we are given that OM. Do you see OM? Is perpendicular to AB. Then we are saying AM is equal to MB. We are saying this is equal to this part here. We need to prove that. How do we do it? Anyone who remembers. If you remember and think you still know, try to be ahead of me. Okay? Right. Otherwise, let's try to move together. Now, we need to prove this. Now, required to prove. This means required to prove. We are required to prove that AM is equal to MB. Now, I'm not going to put the lines there because I haven't proved it. I have to prove it first, then I can put my lines to show that AM is equal to MP. Let's prove it. What do you do? First step, construction. Very, very important. You won't get any marks if you don't do your construction. The first thing that you do is construction. So you must know for this theorem, this is what I construct. Okay? So now what you do, join AO and OB. It's not like all the circles are going to have A, O, B, and whatever. They can use any letters, maybe P, Q, R. You see that? But you must know how to construct. So now the radii, AO, OB, construct. What have we created now? If you check, you should be doing this on a piece of paper, on a book. Please don't just sit and listen. You are not going to learn. As I'm explaining things, you must be doing them. So everyone must be writing something. Okay? Not necessarily writing everything, but the important things. Right. Now we have constructed OA and OB. What do you see, grade 12s? I see two triangles here. AOM and BOM. Do you see these right angle triangles? Okay. Now we need to prove that these two triangles are congruent, and then after that we are going to use congruency to show that AM is equal to MP. Let's prove that these two triangles are congruent. So we have OA is equal to OB, radii. So remember, this is the center from here to there, and then from there to there. It's the same distance. So OA, OB, they are equal, radii, side. And then angle M1, which is this angle here, is equal to angle M2, because this is 90 degrees. This should be also 90 degrees, because angle is on a straight line, they must add up to 180 degrees. So they are equal, M1 and M2, they are equal. Then OM is a common side. So now, what condition do we have here? Side, angle, side. So it shows that these two triangles are congruent. Now you can do your eyebrow, smile, and you will see that AM or MA is actually equal to BM. You see that? MA or AM is equal to BM. OM is equal to OB. We got that. OA is equal to OB. That. This is what we want. This is what we want. MA is equal to MP. So, are we saying this AM is equal to MP? Yes, we have proved that. We have proved that this line, which is drawn from the center, perpendicular to the chord, what will it do? It will bisect the chord. That's the first theorem. Okay, we don't usually name them because books name this theorem differently. So just know the theorem. Just know the theorem. Okay, so AM is equals to MP. Why are we saying that? Because of congruency. One proof that you have now. You have your marks in your pocket now. So if you're going to have this question in the exam about proving this, you get it right. You continue revisiting this. As teachers also, we revisit these things. We don't just come to the lesson without preparing. We have to revisit the things that we learn. Make sure that you remind yourself every time. Okay? Right. Now, my slide is not moving. Okay, it's moving. Right. Now, the line drawn from the center of a circle to the midpoint of the chord is something interesting here. We said the line drawn from the center of a circle perpendicular to the chord, it bisects the chord. It means it goes to the midpoint. So now the other way around, what do we call that? The converse theorem. Now the line drawn from the center of the circle to the midpoint of the chord, what is it going to do? We have the line drawn from the center to the midpoint of the chord. What is it going to do? Or what can you say about it? It is perpendicular to the chord. The line drawn from the center perpendicular to the chord bisects the chord. The other way around, the line drawn from the center of the circle to the midpoint of the chord is perpendicular to the chord. Please remember that. Okay? Okay. And then we can prove that. Let's prove that this angle here is what? is 90 degrees. Now let's remove this. We don't know that this is 90 degrees. We're going to remove that and want to prove it, and then after proving it, then we'll put the sign for 90 degrees. Okay, right, let's start. Okay, before we go, let me emphasize this. Examinable theorem. It means you can be asked to prove this. You can be asked to prove this. So we're given that AM is equal to MP, then OM is perpendicular to AB. The first one that we did, it was the other way around. We're given that OM is perpendicular to AB, then AM is equal to MP. Do you remember that? Okay, so it's like the other way around for this one. Converse. Right. Given the circle with center O with AM is equal to MP, as indicated there, AB is a chord required to prove OM is perpendicular to AB. Right. I want to give people maybe 1 minute to try this, because I know there are some people who have an idea, but if you're still struggling, it's okay. Let me just give you 1 minute to try proving this. 1 minute. Welcome back, grade 12s. Right, I gave you 1 minute so that you can be ahead of me. So if you're still working on the sum, please continue. Okay, I can't give you a lot of time, 3 minutes, otherwise we won't finish the lesson. So continue with the sum. Make sure that you prove it. Right, now, what is the first step? We said what do we do? We do the construction. If you get an idea and then you think that you got it, just do it before me. Okay, right now, construction. What do you think we can construct here? Remember, we're using congruency here, so it means we have to create what? Two triangles. Create two triangles. So construct what? Join OA and OB. You see that? And then you see that. And then what are we given? What do we have? Right. We have that OA is equal to OB. Radii. Radii is plural for radius, isn't it? When there are two, we say two radii. We don't say two radiuses. Okay, say two radii. Radii is for two radiuses. Right, okay? And then OA is equal to OB. And then OM is a common side, you see? It is for this triangle, okay, and this triangle. So it's a common side, so it's equal, okay? And then we have another side, AM is equal to MP. We're given. Now, are these two triangles congruent? Forgot to give you the triangles. We're looking at triangle AMO and triangle BMO. These are the two triangles that we've been looking at. You see that? Okay? Right. And then, so now we can say these two triangles are congruent. Why? Because side, side, side. Okay. Now, if these two triangles are congruent, then this M or MA, which is this angle here, this one, and this angle here, this one, which is this angle here. Let me write like this because I don't know the size of the angle. Right, so these two angles are equal from congruency. Can you see that? Okay, right, from congruency. So we can say angle M1 is equal to angle M2. Why? Congruency. But what is the angle of this point here? This one. The whole thing. AB is a straight line. So M1 plus M2 must give us what? Must give us 180 degrees. But actually these two angles are equal. Okay, two equal angles giving us 180 degrees. So what is the size of one of the angles? You just say 180 degrees divided by 2. And it means one angle is 90 degrees. Do you see that? So, and then therefore M1 is equal to M2, which is equal to 90 degrees. 90 plus 90 is 180 degrees. Okay, remember that. Remember that. Okay, so now we've proved that this angle here is 90 degrees. So we can say that now a line drawn from the center to the midpoint of the chord is perpendicular to the chord. We've proved that. Okay, right, let's move on. Let's try to move on. Right, the perpendicular bisector of a chord. The perpendicular bisector of a chord. Right, this one we are not going to do the proof. You must know how to apply this theorem. Okay, so the perpendicular bisector of a chord, what does it do? The perpendicular bisector of a chord, what does it do? Anyone who remembers that? It means, when I say perpendicular bisector of a chord, means it cuts through the midpoint of the chord. Okay, it means in this case AT is equal to TB. Okay, so this is a perpendicular bisector of a chord and is perpendicular to the chord. So what does it do? Or what can you say about it? It passes through the center of the circle. Remember that. Okay, you have to apply this theorem. Don't worry about proving it. You just need to apply the theorem. Okay, right. Do you think now we can apply what you've learned so far? Okay, you think we can apply what you've learned so far? I want you to try to apply that. It may be difficult, but they are easy things. Remember, if you check for 1 mark, this should be easy, this should be easy, this should be easy. Maybe 4, but it should be easy. 3 marks is not difficult. I want to give you 4 minutes. 4 minutes. You try these 4 questions, and then after 4 minutes, we're going to continue. Let's try grade 12s. Welcome back, grade 12s. I hope you did the right thing. I've seen something when I'm teaching. I've seen this a lot. I've seen some learners who rush to the questions before reading the information. I don't know how they're doing it. You can't do that. You rush to the questions, then the question gives you problems, you start going back to the information. You can't do that. You have to read the information, understand it, then you go to the question. Read the information and get the key points that are going to guide you. So I want you to be able to highlight the key points here. And you are working on the diagram. You don't go out of the examination with clean Euclidean diagrams, Euclidean geometry diagrams. No, you work on the diagram. Put the information that you're given on the diagram. Right, I'll read first. In the diagram, AB is a chord. AB is a chord of the circle with center O. Center O. What am I talking about here? Chord, center. It's to do with center theorem. Line drawn from the center to the chord. Something like that. I have an idea. M is the midpoint of AB. You see, the midpoint, the chord, the center, they're coming up. And then MO is produced to P, where P is a point on the circle. OM is X units, AB is 20 units, and P over OM is 5 over 2. You see, so I have a lot that I can even write before looking at the questions. The diagram, AB is a chord. It's very, very important. With the center O, I don't know why I missed this one, center O, center theorem there. Okay, M is the midpoint of AB, MO is produced to P. Now I can even see that this one, I can say this is 90 degrees. Okay, because a line drawn from the center to the midpoint of the chord is perpendicular to the chord. AM is equals to MB is given. There are a lot of things that you can write about. Right, now, after understanding the information, go to the question. Right, write even the instruction there. Write. 1 mark. It means it's very, very easy. You're not supposed to calculate. So put the information. AB is 20 units. Show that. Show that on the diagram. 20 units. You see that? Write on the diagram. And then what else? P over M is equals to OM. Right. This one, this method that I've used here, we'll do it a lot when we're doing proportionality. But let me explain this. Why did I write 5A and 2A? 5 over 2 can be 10 over 4. It can be 20 over what? 8. Okay, remember equivalent fractions? So that's why I said 5A over 2A, because the A can be a 2, can be a 3, can be what? Because this is not length. It's like ratio. It's ratio. 5 is to 2. Okay, 5 is to 2 means can be 10 centimeters to 4 centimeters. So that's why you put these variables 2A, 5A. Okay, right. And then have I written everything? Right, now write down the length of MP. What did you write, grade 12s? MP is equals to, if AB is 20 units, so MP is 10 units. Do you see mathematics is easy? Just that. Get your mark. It's given because AM is equals to MP. So MP is half of AB. 10 units. Right. Let's move on to the second one. Give a reason why OM is perpendicular to AB. I want you to try that one. If you didn't get it, try again. Why is OM perpendicular to AB? If you did not get it, read the information first. The answer is there. A line drawn from the center to the midpoint of the chord. What does it do? It is perpendicular to the chord. So that's why that angle there, these two lines are perpendicular to each other. Line from center to midpoint of chord is perpendicular to chord. Another mark. Okay, right. And then show that OP is equal to 3x over 2 units. I'm going to show you two methods here. Okay, if you're still trying it, continue, but listen. Now, from P to M is 5a. From O to M is 2a. What about from P to O? It's going to be what? 3a. Do you see that? So it's going to be 3a. Now, what is PM over OM? PM over OM. Sorry, say OP, OP, not PM. OP over OM. OP over OM. It is equal to what? We want OP. You see that? We want OP. So OP over OM is equal to 3 over 2, because 3a over 2a, it reduces to what? To 3 over 2. Okay, cancel, then 3 over 2. Okay, right. Now, what do we do? I want you to put x here. So OP, because OM is what? Is x, isn't it? Over x is equals to 3 over 2. Then what do we do? We multiply both sides by x, and then what do we get? OP is equal to 3 over 2x, okay, isn't it? And then OM, we know that is x, so we put x there, is 3x over 2. Done. Okay? Right. And then the other one that you can do, the other method. So we have PM, we're given that PM, and then OM, which is 5 over 2. Okay? But if you check PM, it is what plus what? PM, it is OP plus X, or X plus OP. Do you see that? So it means actually here where there's PM, we can put OP plus X. So like this. And then what do we do after this? You can try to finish it off. You can what? You can cross multiply. Remember that. You multiply 2 times this. Remember to put this in the bracket. And then 5 times that. Okay, 5 times OM. Remember, OM is X. Okay? Right, try to be ahead of me. Right, and then we multiply, cross multiply, we get something like this. And then let's remove our brackets. It's going to be what? Distribute. Okay, then can I give you 1 minute to catch up? Maybe I move fast. Just 1 minute so that you can try to catch up. Let's try 1 minute. Welcome back. I really hope you managed to catch up. Now let's move together. So we distribute our 2, it becomes 2x. Y is still there. Okay, let's distribute. It becomes 2x plus 2OP is equal to 5x. And then we can transpose this, or do the additive inverses, where you subtract 2x from both sides. So we remain with 2OP is equals to 3x. And then what do we do to get OP? We divide by 2 on both sides. Okay, we divide by 2 on both sides. OP is equal to 3x over 2. We have proved that. That was the question. Okay, right. So this was the first part of our center theorems. We're moving on to something interesting again, and then we're going to be doing proofs. Do you remember proofs? Do you like proofs? Okay, we're going to be doing those. Okay, right. Now, did I finish? It seems like there's question 4. Oh, calculate the value of x. There was question 4. Sorry, learners. Sorry for that. There's question 4. Right, I want you to take note of the following. Let me try to move a bit fast. OP and OB are equal. Why are they equal? Because they are radii. Okay, radii. So OP is equals to OP. So OP, we got that OP is equal to 3x over 2. Remember that we're told to prove that OP is 3x over 2. Some people do that in the exam. You are given that what OP is, and then you fail to prove, then you leave the whole question. But instead, you can use that thing. We're given that OP is 3x over 2. Put it here and get question 4. Get it right. Please don't lose marks unnecessarily. Okay? Right. Now, OP is also equal to 3x over 2 because these two are radii. Okay? Right. Now, if you check, what type of a triangle is this? OMP. It's a right angle triangle. And which theorem is associated with right angle triangle? The Pythagoras theorem. So now we can say that OM squared plus MP squared is equal to OP squared. Pythagoras theorem. Once you've done that, then you're fine. And then you just substitute where there's OM, put x. We have MP, which was 10, and then OP, we just got it now, is just equal to OP is 3x over 2. Okay? Then squared. You square this, you get 9x squared. You square this, you get 4. So you get something like this. Okay? Now it's a matter of how do we solve equations, grade 12s. How do we solve equations? So here we multiply by the LCT, which is 4. Multiply everything by 4. We get that 4x squared plus 400 is equal to 9x squared. Bring the like terms together, or even standard form, and see if it's going to work. Now we have 5x squared is equal to 400. Okay, we can even factorize that. Okay, and then x squared is equal to 80. If we bring 80 this side, it's going to assist us. No, it's not going to assist us. We're not going to have difference of two squares. 80 is not a square number. So we can square root both sides. Okay, find the square root of x squared, find the square root of 80, and then you get that x is equal to 8,94, or you leave it in this form. Okay, right, those are the 4 questions. Let's move on to something interesting, grade 12. The center theorems. Okay. Right, an angle at the center subtended by an arc is twice an angle subtended by the same arc at the circumference. Examinable theorem. Examinable theorem. Okay, right, please don't forget that. So we have this angle here at the center. I'm going to use this one to prove this diagram, to prove the theorem. You see this one here. I'm going to explain everything. What does subtended mean? Some of you are confused now. Okay, right, and then there's this one which looks like a bow tie. Do you know a bow tie? A bow tie is something like this. And then there's something like this. A bow tie is something like this. You see, this thing looks like this, you see. And then there's this one here, and this one, and this one. These are just the same things if you check. Okay, so now I'll explain. I'll bring this diagram again at the end. And then there's this one which looks like a quad. You see this? There's an angle subtended at the center and an angle subtended at the circumference. The red ones are subtended at the center. The blue ones are subtended at the circumference. You see that? Okay, I'll show you these diagrams once again. Let's move on to my explanation. Okay, subtended by an arc means formed by an arc. An angle formed by an arc. You can even use your fingers in the examination. Okay, I'll show you how to use your fingers there to see an angle subtended at the circumference by an arc at the circumference, and an angle subtended by the arc at what? At the center. Do you see now I'm bringing the term arc? You see that? Now, angle Y is subtended by arc. Which one? Which arc? If you can name the arc there, please do so. Angle Y is subtended by arc. Which arc? AB. Do you see arc AB? Okay, it subtends the angle. The angle is formed by that arc AB. It's like this thing is sitting on the AB. You see that? Okay, right. You can put your fingers there on A and B, and then you move along the lines till you get to the circumference. Let me show you using the arrows. Right, you can put your fingers like this, you see, on A and B, and then you move following the lines till you meet at the circumference there. So that's where the angle is formed, at the circumference. So angle Y is subtended by arc AB at at the circumference. At the circumference. Do you see that? So angle Y is formed there at the circumference. Do we have another angle which is subtended by arc AB? Yes, we have. Which angle is that? X. But where is it subtended by arc AB? At the center. Again, you can put your fingers there on A and B, and then you move along the lines till you get to the center there. You find angle X. So we've got two angles now subtended by the same arc. The other angle is subtended by that arc at the circumference. The other angle is subtended by that arc at the center. There's a good relationship between these two angles, between X and Y, which is a theorem that we're going to talk about. Okay, so we are saying that an angle subtended by an arc at the center of the circle, which is what in this case? Angle what? X, isn't it? This angle is double the size of angle subtended by the same arc at the circumference. It means this X here is 2 times Y. Okay, let's play the game. If X is 20, what is Y? It should be 10, isn't it? If X is 50, what is Y? Y should be 25. If Y is 5, what is X? If Y is 5, what is X? X should be 10, isn't it? The angle subtended by the arc at the center of a circle is double the angle subtended by the same arc at the circumference. X is 2 times Y. Y is half of X. Please don't forget that. So this is the reason we write angle at center equals 2 times angle at the circumference. Please don't forget that. We're going to prove that. Now, given a circle with center O and ABC are all points on the circumference of the circle, we want to prove that. You have to remember now your theorem, your Euclidean geometry from the lower grades, okay? Right, we are required to prove that AOB, do you see angle AOB? I want you to be able to see the angle. AOB is 2 times angle ACB. This angle here is 2 times this angle here. I want to prove that. Angle subtended by the arc at the center of the circle is twice the angle subtended by the same arc at the circumference of the circle. Don't forget that. Now, construction. You see that every time you're proving, there is what? There is construction. You start writing things without constructing, you are not going to get any marks. Construction, very important. So now, join CO and produce to N. You see that we have created 2 triangles. We like creating 2 triangles if you check, okay? Right, we have triangle AOC and triangle BOC. Do you see those triangles? Try to identify them. Triangle AOC and triangle BOC. Right, what can we say about OC and OA? They are equal. Why? Radii. What can you say about OC and OB? They are equal. Why? Radii. Okay, so think about angles opposite equal sides. Okay, think about the exterior angle of a triangle. Think about those things. Right, let's do it together. Now, or let me just name the angles so that it becomes easy for us. Okay, you are required to prove that AOB is 2 times ACB. So what you do after constructing in triangle ACO, look at triangle ACO. So we can say that O1, do you see angle O1 is equals to C1 plus A. Why? Exterior angle of a triangle. So if you add C1 and A, you are going to get O1. Okay? Right. And then but C1 is equals to angle A, because they are, what did I say here? Oh yes, because they are, C1, angle C1 is equal to angle A, because radii OA is equal to OC. Usually I use the angle, angles opposite equal sides. That's why it was a bit confused there. Angles opposite equal side, because OC and OA are equal. So this angle and this angle are equal there. You see that? Because angles opposite equal sides. And then, so it means O1 is equals to 2 times C1. Do you understand that? Because this is C1, this is just like C1, because these angles are equal. This is like C1 because they are equal. So it means O1, we're just saying C1 plus C1, which is 2C1. So this angle here is 2C1. Okay? We go to the other triangle now. Okay? Don't forget that this angle is 2 times angle C1. Okay? Let's go to the other side. Now, we go to the other side. Okay, I have my animation there. Don't let me not worry. And then we have what? This O2 is equal to what? C2 plus B, angle B. Okay? Because exterior angle of a triangle, remember this, grade 12s. This angle plus this angle will give you this angle here. Exterior angle of a triangle. Okay? Right. And then now, but C2 and B, angle B are equal. So I can even write here and say this is C2. I can also write here this is C2, because these two angles are equal. So it means this is 2 times C2. Okay? So this is actually 2 times C2. C2 plus B is just the same as C2 plus C2, which is 2 times C2. So angle O2 is 2 times C2, which is like that. You see that? Okay? Right. I want to give you 1 minute to try and catch up. Maybe someone is still trying to understand, and then 1 minute, then after that we continue. Let's try to catch up for 1 minute. Welcome back, grade 12s. These things may look difficult, but they are not difficult. So what are you supposed to do? Make sure that after this, you redo these theorems. Do all the proofs that we have done on your own till you get everything correct. Please, let's try that. Make sure you try that. And then now, so this is C1 plus 2C1 plus 2C2. If you combine these two, we are adding these two. 2 times angle C1 plus 2 times angle C2. Okay? And then let's add this one here. So this one is going to be angle C1 plus angle C2. Okay? And then this one here is going to be angle 2 times angle C1 plus 2 times angle C2. You see that when you add these two. Okay? So that's what I'm going to be using now. Okay, so we have O1 plus O2 here. You see, which is this, which I've written here. You see that? That is O1 plus O2. Okay, and then now we can do this. If you check, O1 plus O2 is angle AOB. This is AOB. You see that? That is AOB. And then what is C1 plus C2? It is this angle ACB. It is this angle here, ACB, this one. This is C1 plus C2. So here I'll just replace this with ACB. I'll replace this with ACB so that it looks like this. Do you see that? So we can now see that angle AOB is 2 times angle ACB. We have proved the theorem. I really hope that you manage to gain something from this, but remember what I have said. After this, you try to do these theorems on your own. Okay? Right. Just a single lesson cannot be enough for these theorems. You have to try after this. Right, and then, so I've messed my animation there, but it's fine. So now we are going to say this red angle here is 2 times the blue angle. That's the theorem. Okay, so angle at the center is equal to 2 times the angle at the circumference. Angle subtended by the arc at the center is 2 times the angle subtended by the same arc at the circumference. Okay, please don't forget that. Now, still on the same theorem, what is this angle here? What is this angle here on a straight line? Who can tell us? That is actually 100 and what? 180 degrees. Okay, what is half of 180 degrees? It is 90 degrees. So an angle subtended by the diameter is what? Is 90 degrees. It's another theorem. Okay, the angle subtended by the diameter at the circumference of the circle. Very, very important. Where? At the circumference of the circle. Please don't be confused. Don't be. I've seen people get triangle like this, and then let's say there's a diameter there, okay, and then there's a line going like this, and then a line maybe going like this, and then they say this angle here is 90 because of the diameter there. No. The angle must be subtended at the circumference. It must be at the circumference. The other misconception is this one. You find then there is a chord. We're not told that it's a diameter, it's a chord. If you are not told that it passes through the center, it's not the special chord, the diameter. No, it's a chord. So if you get like that, this is not what? This is not a diameter. So unless you're told, okay, or it's implied that it says what? Is diameter. Ne? Okay, don't assume. In Euclidean geometry, never assume. You must be given information directly or indirectly. If you can prove that AB is diameter, then you can conclude that this one is what? Is 90 degrees. Or if you are given that AB is diameter, then you can say this angle C is what? 90 degrees. But do not assume. Okay? Do not assume. So the angle subtended by the diameter at the circumference of a circle is 90 degrees. Please don't forget that. You see a diameter, you see angle subtended by that diameter at the circumference. You have a mark for that. Okay? Please don't lose marks unnecessarily. So reason here, we say angle, let me write it here. Angle in, oh, I have a lot of them. I'll end up messing up everything. So this one is what? You say angle in the same circle. This one is the most popular one. Angle in the same circle, or angle in half a circle, or you can say what? Diameter subtends right angle. So any of those reasons, they are okay. Okay? Right. Now, let's move on. Right, the converse, the other way around now. If the angle subtended by a chord at the circumference is 90 degrees, then it means what? It means the chord is a diameter. Right. If I give you a diagram like this, and then I say this angle is 90 degrees. Let me name them A, B, C, D. Right. Angle B is 90 degrees. What is angle D? This one. It should be 90 degrees, because if this is 90 degrees, then this is diameter. It passes through the center. And then if this is diameter, then this is 90 degrees. Interesting, because we're going to be doing angles, opposite angles of a cyclic quad. Okay, 90 plus 90, 180 degrees. But let me not talk about that today. Right, okay, so reason here we say converse angle in a semicircle. That's the converse. If the angle subtended by the chord at the circumference is a circle, then that chord is diameter. Okay, right. Now I want to sort of summarize this part of angle subtended by an arc at the center being 2 times the angle subtended by the same arc at the circumference. Okay, you can have these different diagrams. Okay, just know them. This one is the easy one to identify, but there's this one also. Do you see that this is angle subtended by the chord, by this chord AB? This one is at the center, this one is at the circumference. So the Z here is going to be half of 270. There's 270 here. You see that? Please take note of that. And then there's this one. We talked about this one, straight line diameter, then this is 90. And then also we talked about the one that looks like a bow tie. You see, they can be in different shapes, different orientation. You see that? Please try to identify that. Just use the fingers. Like here, I put my finger there. I put my finger there. I move to the center. I go back. And then I move to the circumference. You see that? I move to the center, go back, I move to the circumference. Okay? You do that, move to the center, okay, go back, move to the circumference. You see that? You move to the center, you go back like this, and then move to the circumference. You can even play around with the fingers. The center, circumference. You're starting from what? From the arc here. Always. Arc. You see that? You're starting here. Center, circumference. Okay? Then you see that this is an angle subtended by this arc at the center, angle subtended by this arc at the circumference. It's like I showed you using my arrows there. Please don't forget that. And then I thought this one looks like a bow tie. I just wanted to show you, right? Okay. You see that? You're moving here, then you're moving there. You see? Okay. Right. Now, the activity. In the diagram, O is the center. I'm thinking about center theorems now. Are they going to talk about the chord? Are they going to talk about the line from the center to the midpoint of the chord? I'm not sure. Okay, let's see. In the diagram, O is the center of the circle passing through A, B, and C. CAB is equal to 48 degrees. COB is equal to X. Angle C2 is equal to Y. And then if I look at the diagram here, I don't see a line drawn from the center of the circle to the midpoint of the chord. I don't see that. So it should be this theorem about what? About angles at the center. Sorry, angles subtended by the arc at the center and angles subtended by the arc at what? At the circumference. You see? Which arc subtends angle X? Which arc subtends angle 48? Ask yourself those questions, okay? Before you even look at the questions, just ask yourself, looking at the information. Now I'm going to give you, 4 minutes will be too much. I'm going to give you 3 minutes to try to determine the value of X and Y. 2 minutes. 3 minutes. 3 minutes. Let's try. Welcome back, grade 12. Do you get the correct answers? Let's see. Angle X subtended by arc CB at the center. Angle 48 degrees subtended by the same arc at the circumference. So what will be angle X? Angle at the center subtended by an arc at the center is 2 times the angle subtended by the same arc at the circumference. So it means X is going to be 96 degrees. Okay, and then there's a reason there. You see that? Okay, right. Now, so now where there's X, we can put our 96. Remember I said you must write on your diagram. So now we have 96 there. We want to find angle Y, angle Y. Okay, we want to find angle Y. So now C2 plus B2 plus X is equal to what? If we check this, what do you see here? What do you see here? You see what? A triangle. What type of a triangle? An isosceles triangle. And then we know that angles opposite equal sides are equal, meaning that C2 and B2 are equal. Do you see that? Okay, now we want to find C2, which is our Y, isn't it? We want to find C2, which is our Y. So angle is C2 right now. So but C2 is equal to B2. I've explained that because it's angles opposite equal sides. Okay, so now where there's B, angle B2, we can put angle C2. So we can say this is C2, the angle. This is also C2, the angle there. Okay, right. So we can add and say 96 plus C2 plus C2, isn't it? Okay, right. Remember that. And then so 2C2 plus 96. This C2 angle C2 and then this angle C2 becomes 2 times angle C2 plus this 96. They give us 180 degrees because they are angles in a triangle. Okay, angle sum in triangle. That's the reason you write. Okay, now we can solve for what? For our Y. Remember, this is Y. This is Y. Okay, so now we solve for Y there. And then we transpose. And then we divide by 2 both sides. C2, which is equal to Y, is equal to 42 degrees. Was it difficult? You see, the most important thing is recognizing the things that you are given and what you're supposed to do. The calculation part is not difficult, grade 12s. So the most important thing is for you to understand the information that you're given. Calculating is what we've been doing since we started mathematics. Okay? Right, take your time to understand the question. Right, another question. I'm going to give you another 3 minutes to try this one. Another 3 minutes. This should be the last question, I think. And after that, we'll summarize our lesson. Try this one for 3 minutes. Welcome back, grade 12. Let's try to do this together. O is the center of the circle. Interesting. What comes to my mind? O is the center. It could be a line drawn from the center to the chord, or an angle subtended by an arc at the center. You see, already I have an idea. KOM bisects the chord. Interesting. So there's a chord in it. So there's a line from the center to the chord. Is it bisecting the chord? Interesting. It's bisecting the chord because M is the center there. You see that? So try to get the information before you even look at the questions. Right? MNO is 26 degrees. Write that information on the diagram. Is it given? Yes, it's given. So it's fine. Yeah. And then K and P are points on the circle. And then NKP, angle NKP is 32 degrees given there. And then OP is drawn. Right. Okay. Determine with reasons the size of angle O2. Right. If you're using gadgets or tablet or whatever, I want you to use your fingers like this. Okay. If you're in the classroom, you're looking at the screen, one person can stand up. I want one person to stand up and go to the screen. Okay. If you're using a tablet or your phone or something, you can use your fingers, don't need to stand. But if in the classroom, you stand up. One person can do that. Okay, let's try that. I'll tell you what to do. Okay, right. Now, if you are on the screen, if you are next to the screen there, you put your two fingers on P and N. On P and N, you try to follow those lines towards the center. Right, from P and N, let's move to the center. If you're using your fingers, you move like this to the center. P and N, move to the center. Okay, and B, they meet at the center. What angle is formed there? It should be O2. Do you see that? It should be angle O2. You go back to PN, start afresh. Now we're going to form the angle at the circumference. Let's go to the circumference. What angle is formed there? It should be K1, which is 32. Do you see that? So we can use our fingers. From PN to the center, we go back from PN to the circumference. You see that? So the angle which is subtended by the arc at the center is 2 times the angle subtended by the same arc at the circumference. So what is the size of angle O2? Everyone must get this one right. It should be 64 degrees. Do you agree? It should be 64 degrees. The angle at the center is 2 times the angle the angle subtended by an arc at the center is 2 times the angle subtended by the same arc at the circumference. So this O2 is 64 degrees. Don't forget the reason. You have used that part. Now we want to find O1. We want to find O1. Now what else are we given? This line here, OM, is drawn from the center and it bisects the chord NL. So meaning that we have a line from the center bisecting the chord. What does it do? It is perpendicular to the chord. So it means this angle here, M2, is 90 degrees. We're going to get O1. Remember that. Okay? Right. And then now, if you check, there's angle 26 and angle 90 here. If we add these two angles, which angle are we going to get? Let me draw this. Something like this. There's 26 here. There's 90 there. Which angle is formed? Here, if we add exterior angle of a triangle. Which angle is that? Is KON. Do you see that? So we can find angle KON by saying 90 plus 26 because exterior angle of a triangle. So KON is what? It is 116 degrees. You see that? So now we have this angle KON being 116 degrees, but we can then subtract this from 116 degrees to get the O1 because this whole thing is 116 degrees and then this one is 64. So we can subtract and say 116 minus 64 and then we'll get what? Our O1. Do you see that? We can do that. Okay? And then you do that and then you get that O1 is 52 degrees. Do we have another method? Yes, we have. As long as you are doing your mathematics correctly, you will get the same answer. Okay, so don't stress. Now, that is 52 degrees. Okay, or I said, now you can do this. Now this angle here, M2, is 90 degrees. We agreed. Then we can find O3 using what? Angle sum in a triangle. So 90 plus 26 plus O3 must give us 180 degrees, because these are angles in a triangle. Okay, and then we get O3. So it means O3 is 64. What about O1, O2, and O3? If we add them, what must it give us? They must give us 180 degrees, because these are angles on a straight line, adjacent angles on a straight line. So now O1 plus O2 plus O3 must give us 180 degrees. So O1, we just subtract O2 and O3. We will get our O1, which is what? Which is 52 degrees, because we said O1, angle O1 plus angle O2 plus angle O3 is equal to 180 degrees. Okay, with the reason. Don't forget the reason. And then we have O2 and O3. So O1 plus 64 degrees is equal to 180 degrees. And then if you transpose these ones, they come this side, both of them. That's why we have this. Minus 64 degrees minus 64 degrees. Okay, and then we get O1 is 52 degrees. Do you see we are getting the same answer? We are getting the same answer. Okay, right. Now, I want you, do we have another question? Okay, let's go to the last one. And then after that, I'll give you 1 minute to sort of try to catch up. Prove giving reasons that Kn bisects OKP. Check, this is OKP, the angle OKP. So if this angle is 32 degrees, it means this one also must be 32 degrees. So if we prove that K2 is 32 degrees, then we have proven that this line Kn bisects, means cuts the angle into two equal parts. Okay, so let's find the angle K2 there. Right, PKO is equal to P, this angle, these two angles, you see the ones I've marked in red, they are equal. Why? Already. OK is equal to OP. Okay, angle is opposite, equal size. Okay, right, and then we have 52 here. So it means that we subtract 52 from 180 degrees and divide the answer by 2, we'll get these two angles here, because these two angles are equal. So you just say 180 minus 52 degrees divided by 2. Because why? Sorry, can you say because why? No, it's not wrong. Because angle sum in a triangle. Angle sum in triangle. 52 plus K or KP plus KPO, they must add up to 180 degrees. See that? And then because these are equal, if you subtract 52 from 180 and divide by 2, we'll get these two angles. And then it means PKO is 64 degrees. Now this whole thing, this whole angle is 64 degrees. And then to get K2, you say 64 minus 32, which is 32 degrees. We've proved that K2 is what? Actually 32 degrees. So this line KN bisects the angle OKP or PKO. Right. I really hope that you learned something great to us, but I want to give you just 1 minute to try and digest what we have been talking about. Then after that, we summarize. Welcome back, grade 12s. Let's see. Let's summarize our lesson, but after summary, we still have a few minutes. I'll go back to one of the proving one of the theorems so that maybe we can benefit from it. Right now, let's move on. Let's summarize. What did we say? The line drawn from the center of a circle to the midpoint of a chord is perpendicular to the chord. Okay. A line drawn from the center of the circle to the midpoint of the chord, what does it do? It is perpendicular to the chord. Right. And then this is examinable. You can find this proof in the exam. The line drawn from the center of a circle perpendicular to a chord bisects the chord. This is okay. Oh, they almost sound the same. I almost said it's repetition. Right. Here is to the midpoint. This one perpendicular, the converse of that. To the chord, it bisects the chord. Okay. And then the perpendicular bisector of a chord passes through the center of the circle. We must know how to apply this theorem. And then the angle subtended by an arc at the center of a circle is double the size of the angle subtended by the same arc at the circumference. Sorry, at the circle. Let me read this again. The angle subtended by an arc at the center of a circle is double the size of the angle subtended by the same arc at the circumference of the circle. Please take note of that. Circumference of the circle. Right, this is examinable. And then the angle subtended by the diameter of the circumference of the circle is 90 degrees. This is what? You must know how to apply this, okay? Right, now, this is our summary. And then if the angle subtended by a chord at the circumference of the circle is 90 degrees, then the chord is a diameter. These are the theorems we talked about, grade 12s, okay? Right, whilst you are waiting for our time to get to past, I can just let me pick one, okay? One that we can just redo and see if we can manage to do it. Right, now, let's say we have our circle here. Let me try to draw it. Okay, we have to prove, let's say this is the center. We have to prove what? Let's say this is A, B, C, and then O. Right, what are we required to prove here? That this angle here, BOC, right, BOC is equals to 2 times angle BAC. Okay, see that? And then what do we do? What do we do, grade 12s? What did we do? We constructed construction. We're going to draw a line. There it goes. You see that? And then we have created 2 triangles there, okay? Right, what can you say about, let's name our angles. This is O1, O2. This is A1 and A2, okay? Right, you see that? Now we can say this angle here is equal to this angle here because OA and OB are equal. Right, this angle, let me try to, if I can pick different colors. Right, this angle here is equal to this angle here because they are what? Angle is opposite equal sides. OA is equal to OC. You see that? And then now this is an exterior angle. If we look at this, this angle and this angle. So this one is going to be, this is A1. This is A1, isn't it? Let me also say this one is going to be A1 because these 2 angles are equal. This is A2. Let me call this one also C, A2, because they are what? They are equal. So this angle is going to be A1, 2 times A1 in this one. And then this one is going to be 2 times A2. Do you see that? Okay, I'm not doing the whole thing, but I'm giving you an idea. No? And then now we have A1 plus A2 here. And then we have 2A1 here plus 2A2 here. So we're saying this angle BAC is equals to A1 plus A2. We see that. And then what about BOC? BOC is equal to 2A1 plus 2 what? 2A2 2a2, yes. And then I can factorize this. I can factorize here. Let me just finish. Plus a2. If you check, this is this. This is this. Now we can say that BOC is equals to 2 times BAC. You see, we have proved that. We have proved that the angle subtended by an arc at the center is 2 times an angle subtended by the same arc at the circumference. Right. Well done, grade 12s. I really hope that we are going to meet again next week, and we are going to do more lessons. We're going to do Euclidean geometry, and we are going to benefit a lot from these lessons. Let's meet again next week. Remember to sanitize, to social distance, and to always wear your mask, and to take care of each other. Goodbye.